We have a beautiful cloud.
Trap made today with two M6 nuts and 8 rods from CD-ROM. AC voltage is put on both nuts and plexiglass laser cut.
Now released most particles from the trap, only 3 are left.
Now we have only single particle, half kilovolt. I can raise the voltage. 2 kilovolts, it's becoming unstable. Single particle, 400 Hz. We definitely need to make DC voltage adjustments. Increasing AC voltage produces instability of the most highly charged particle. And this is when Q factor becomes larger than 1 in Mathieu equation. Changing vertical DC voltage from 0 to 1000 volts. Particles swap their places very nicely. Interesting motion. Increase DC voltage of the rods.
Looking in the trap from above.
What happens with time? As particles lose their charge, they are pushed more together. L'utilise show figure for the first time. Increasing DC, decreasing DC. 0 DC. Now only single particle is left. If I increase voltage, it starts to become unstable. This is DC voltage. So that's another stability criterion. From all 3 particles, the one which was left is the one which has this instability. With this last trap particle, AC voltage is about 200 volts and DC voltage about 70 volts.
Two days later, the same particle, still trapped. This is trap on the circuit board. And here we have 2 dust particles. And they look like this. When I put higher voltage, we get discharge. I would say the distance is too small and we get a discharge. Things try to fly to the right side and out of the trap. Somehow the particles like to run to the right side. Reloading. Why they are falling down? They are not being trapped. Maybe they are not charged. And we have quite local trap place. Oh, this is fun. Dust likes to sit on one side and in the widest place. And now we see such effect. Some particles come in and others leave. At 70 Hz, quite low voltage, 500 volts. 70 Hz particles like to group at the end of the narrow electrode. This is at 100 Hz. We have some particles on one side and on other end. Things are getting better after putting aluminum foil on the bottom to prevent static charge from plastic. Apparently it's not good to put things on the plastic because of static charges. Things became better. Now the forest looks almost like in the publication. Trap at 400 Hz. Well, it works, but could not get much nicer. Big discharge created such effect. The box is too big, convection is strong. A piece of taser band can disturb everything. Hop. At the end, one conclusion is that dust has fallen down on the circuit board, creating insulating islands which are charging up and making local minima for ions. I cannot recommend to repeat this trap because it's simply too monstrous. A new trap, edges machined with Dremel, are not good because they are sharp and discharge happens easily, even if distance is large. The trapping is so-so. It's not over the central electrode, but in the gap between electrodes and mostly at the ends. And now I will show what happens when discharge goes on. And now the ring trap. Inside is at 0, ring at high voltage AC, and outside is at 0. We have interesting picture. There are ions dancing around the center, like around the bonfire. And again, dancers are not in the middle, but they are somewhere between two tracks. At 260 Hz we have 4 stable particles and one is high above. Effect of DC voltage. This looks cool. Like small spirals. Same with discharge. Effect of DC voltage. Voltage 0, increasing voltage. Discharging is a large problem because they have narrow edges and sharp. Discharge problem eliminated by spraying machine oil between the circuit board traces. After putting oil between traces, I can raise voltage to 3 kilovolts without any discharge, and particles collect over the center electrode. Here I decrease the DC voltage, here I increase the DC voltage. Oops. For a single particle, in principle, it should be possible to cancel micromotion. Loading the trap. So we trap many dancers. 3 kilovolts, 300 Hz. For vertical rods did not help. to put the charge in the center. Soldering rods did not help. The particles are in different locations, not localized in center. It's fun to see how oil moves with AC voltage, but there is no sparking, which is good. Back to the trap, which gave the best results. And first try with audio transformer from lamp radio. It gets pretty hot and starts to drop paraffin. An attempt to put transformer in mineral oil. Audio amplifier on the rear. Both channel outputs are in parallel, and audio is taken from computer